Today we're going to continue learning how to graph systems of equations. So let's start with this system which says y equals negative x plus 1 and x equals 3. We know that the solution to a system of equations is the point where the two lines intersect. So we need to graph both of these lines on our coordinate plane. So we're going to start with y equals negative x plus 1. We know that if we're graphing a line, we're always going to start by graphing our y-intercept. Our y-intercept for this equation is positive 1 because it's plus 1. And our slope is then used to find another point or several points. So for this problem, our slope is, it looks like there's just a negative in front of our x, but we know that that actually means that there is a negative 1. So our slope is negative 1. Now, I also need to remember that slope, in order to be graphed, has to be in the form rise over run. So I can take my slope, which is negative 1, and I can place a 1 underneath that. That is the same as a slope of negative 1. We also learned last week that if I have negative 1 over positive 1, I can take my negative sign and I can flip it down to the denominator. And this makes two equivalent fractions, because if I do negative 1 divided by positive 1, that gives me a slope of negative 1. Or if I do positive 1 divided by negative 1, that still gives me a slope of negative 1. So even though these look different, they are actually the same thing. So let's take this and graph this line. We're starting with our y-intercept of positive 1. So if I start from my origin to get to a y value of positive 1, I would move up 1. Then from there, I'm going to use my slope. So my slope was negative 1, but we had to write it in the form rise over run. So that's the same as negative 1 over positive 1. If I have a negative 1 for rise, I would move down 1, and then a positive 1 for run would mean I would move right 1. So I can continue that, down 1, right 1, down 1, right 1, down 1, right 1, until I have a lot of points. I also can go in the other direction by using this form of the slope, which is positive 1 over negative 1. So I would have had a rise of positive 1, which is up 1, and a run of negative 1, which is left 1. And I can continue in that direction as well. So up 1, left 1, up 1, left 1. Now I'm going to take my line and I am going to connect these points. Well, maybe. And there is my graph. Now I need to do the same thing for x equals 3. And x equals 3 looks strange because it's not in the form y equals mx plus b, but I need to take my points, and I need to find the place where x is equal to 3. So to get to x equals 3, I need to remember my x-axis is this horizontal axis, so I would move right 3 units. And that is a point where x is equal to 3. Now to make a line, I have to have more points. So I need to think about the fact that if I'm making a line and everything on the line is equal to 3 for its x value, that means the y values can change. So if I'm changing my y values, that means that I'm moving up or down. So from here, I can move down and my y value will change, but my x value will stay the same. I also could move up. Again, my y values are changing, but my x values are still positive 3 here. Now, I have created some points that I can now connect with a line. And what I'll notice is that I'm making a horizontal line. And my solution to this is the point where these lines intersect. And these lines intersect at this point. So The ordered pair for this is my x value, so I would move 1, 2, 3 to the right to get there, and then my y value, and I would move down 1, 2. So that means because I moved right 3, I have an x value of positive 3, and down 2, I have a y value of negative 2. So this is the solution to this system of equations. Now let's look at this next example. For this problem, I have y equals negative 5/3 x plus 1. So in this problem, again, if I start with my y-intercept is plus 1, so it's positive 1. My slope is negative 5/3. So it's already written as a fraction, so I don't have to worry about that. But what some of you had questions about last week was the fact that in this problem, the negative is on the outside of the fraction. So you weren't sure where that went. Well, if you have a negative, that means that the value of the entire fraction is negative. So that means that either the numerator is negative or the denominator is negative. Because in both of these cases, if I did 5 divided by 3, but negative 5 divided by positive 3, I would get a negative value. In this case, if I did positive 5 divided by negative 3, I would get a negative value. So these look different, but they, again, are equivalent. So let's graph this line. Again, I start with my y-intercept, which we said was positive 1. So I go up to positive 1 on my y-axis and put my point. Then I'm going to go from there, plot more points using my slope. So my slope was negative 5/3. I'm going to use this one, negative 5 over positive 3. So that's a rise of negative 5, which means I'm going to move down 5 units. So down 1, 2, 3, 4, 5. And then a run of positive 3, so that means I will move right 1, 2, 3. So this is where I would put my point. Now, I also could have used my slope of positive 5 over negative 3, which meant I would use positive 5 as a rise, so up 5, which would put me a little bit off of my graph. And then I would use negative 3 as my run, so that would be left 3, and I would have a point here. Now I can connect these points with my line. I'm not doing a good job of it, but there it is. All right, so now let's look at our next problem, which says y equals negative 1/3 x minus 3. So again, I start with my y-intercept. In this case, my y-intercept is minus 3, which means it's negative 3. My slope is negative 1/3. And again, that negative is on the outside of the fraction. That means that the whole fraction is negative. So that means that either the numerator is negative or the denominator is negative. So let's look at our points. We're going to start with our y-intercept. So we will move down to negative 3 on the y-axis for our first point. And then let's look at our slope. If I use my first slope, which is a rise of negative 1 and a run of positive 3, rise negative 1 is down 1, run of positive 3 is right 3. And when I do that, I actually intersect with my first line. So I can go ahead and connect these because I don't need any more points. I've already found the point where these two intersect. So I will draw my line. Which is hard to do using one of these, sorry. And so there's my line, and you can see where they intersect, even though I didn't draw it that well, so they don't intersect perfectly, but you can see where their points intersect. So The solution to this is where they intersect, and the solution is this point right here. So to find the value of this point, I would start at the origin. So to get there, I would move right 3 units, and then I would move down 4 units. So the solution to this problem is going to be positive 3 as my x value and negative 4 as my y value. So this would be my solution. All right, so let's look at another problem. For this problem, we have 5x plus y equals 4. Now, if you're looking at that and you think that looks strange, it's because it does. In order for you to graph a line, it has to be in the form y equals mx plus b, which means y has to be on one side of the equation by itself. But in this equation, I have 5x on the left side of the equation with y. So I need to use the inverse operation to get rid of 5x, which means I'm going to subtract 5x from both sides. 5x minus 5x will cancel, and that leaves me with plus y, which is just positive y. On this side, I have 4 minus 5x. These are not like terms, so I cannot combine them. So instead, I'm just going to write them. Now, I'm going to write it so that I have my x first, because that's usually how a linear equation is written. This says minus 5x, which means it's a negative 5x. And then I have a positive 4 here. Because it's positive, I'm going to write plus 4, and that shows me that that value is positive. Now my y is by itself, and now this looks like an equation that you know how to graph. So again, we start with our y-intercept, which is plus 4 or positive 4. Then we use our slope. In this case, it's negative 5. But I need to remember that slope needs to be in the form rise over run. So if it's negative 5, I can put that over 1. That's the same as saying positive 5 over negative 1. So let's graph that equation. My y-intercept is positive 4, so I'll go up to positive 4 on my y-axis. Then I'm going to use my slope. My slope is negative 5, but I use negative 5 over positive 1. So if I have negative 5 as my rise, I'm going to move down 5 units. And then if I have positive 1 as my run, I'm going to move right 1 unit. So that was down 5, right 1. Now, if I go down 5 again, I'm going to go off my graph. And if I had started right here and I had used positive 5 over negative 1, that would have meant that I had a rise of up 5, and that also would have gone off my graph. So for this, I'm just going to use these 2 points because that looks like that's probably about the best that I can do here. All right, so there's my 2 points. And now let's look at our next problem, which says x minus y equals 2. So for this problem, again, I don't have x by itself, or y by itself, I'm sorry. So x is on this side of the equation. I need to get rid of it. To get rid of it, I am going to subtract x from both sides of the equation. These are going to cancel out. Now you have to be careful here because I'm not left with y on this side of the equation. I'm actually left with negative y. And then I have 2 minus x, or I can write that as it's a minus x, so that's negative x, and it's a positive 2, so I could write plus 2. Now, it looks like y is almost by itself, but it's not. It has a negative sign with it. And actually, we know that if we don't see anything there, that actually means that there is a negative 1 right there. So that really means that this is saying negative 1 times y. So the inverse of that is going to be to divide negative 1 on both sides. That will cancel these out to leave me with y on this side of the equation. Now, over here, I need to be careful because I need to make sure that I divide every term by this negative 1. This is negative x divided by negative 1. Again, remember, there's a negative 1 here that I don't see. So negative 1 divided by negative 1 is positive 1. So it's positive 1x. And positive 1x is the same as just x. Then I have positive 2. I know that it's positive because of that plus sign, divided by negative 1. If I have positive 2 divided by negative 1, that gives me a negative 2 as my answer. Well, if my answer is negative 2, I'm going to write minus 2. So now my equation is in the form y equals mx plus b. And now I need to use this equation to find my y-intercept and my slope. So my y-intercept is this minus 2, so negative 2. My slope, it looks like there's nothing in front of the x. But if there's not anything in front of the x, I know that that actually means there's an invisible 1. And again, if I am going to write that as a fraction, that's going to be 1 over 1. Now, when you have a positive slope, the tricky thing about this is remembering that that's the same as saying a negative over a negative, because negative 1 divided by negative 1 is still a positive 1. So let's take these values and graph them. If I start with my y-intercept of negative 2, I'm going to move down to 2 on my y-axis. And then I'm going to use my slope to find some more points. So if I start with my slope of 1 over 1, that's a positive 1 as a rise and a positive 1 as a run. So that's up 1 and right 1. And at that point, I've already intersected with my first line. So I don't need any more points. So I will go ahead and take my line and connect these points. And you can see right where they intersect, which is right here. And that point is 1 right from the origin and 1 down. So that means it has an x value of positive 1. Whoops, sorry. And a y value of negative 1. So the solution to this is positive 1, negative 1. All right, now let's look at this problem. So for this, we have x minus 4y equals negative 4. Again, y is not by itself, so the first thing I need to do is get rid of this x by subtracting x from both sides. These will cancel. I'm not left with 4y, I'm actually left with negative 4y. On this side, both my 4 and my x are negative, so I'm going to write this as negative x minus 4. I need to get rid of this negative 4. Negative 4 is being multiplied by y, so the inverse of that is dividing by negative 4. So I need to do that on both sides of my equation. These will cancel and leave me with y, and then equals. And again, I need to make sure I divide by negative 4 by every term. I need to make sure right here that I remember there's a 1 here that I don't see, so that's really a negative 1 over negative 4. If I do a negative 1 divided by a negative 4, I know that that's going to give me a positive value. And if I just divide it, that's going to give me a decimal. But I don't want a decimal, so I'm just going to leave that as a positive 1/4 times x. Then I have negative 4. I know it's negative because of that minus sign, divided by negative 4. And negative 4 divided by negative 4 is positive 1, so I'm going to write plus 1. Now, we'll use this to find our y-intercept, which is right here, positive 1, and our slope, which is our coefficient of x, so in this case it's 1/4. And 1/4, because it's positive, is actually the same as writing negative 1 over negative 4. So we're going to start with our y-intercept, which is positive 1. And then we'll use our slope to find some more points. So if we use our slope of positive 1 over positive 4, that's up 1 as my rise and right 4 as my run. Now, if I continue from there, I'm going to go off my graph. So I'll go back to my y-intercept right here, and I'll use negative 1 over negative 4. So that's down 1 and left 4. So my line's going to look like this. I'm going to take this and I'm going to plot it here. right, so there's my line for this. So now let's look at our next problem. So for this next problem, we have 5x minus 4y equals -4. Again, I need to get y by itself. So I'm going to get rid of the 5x first by subtracting 5x from both sides. 5x minus 5x will cancel, and I'm not left with 4y here. I'm actually left with -4y. On this side, I have -4 and -5x. They're not like terms, so I'm just going to rewrite them. And I'm going to usually start with my x. So it's minus 5x, which means it's -5x. It's -4, which means I'm going to write -4. Now y is still not by itself, so I'm going to divide by -4 on both sides of this equation. Now those cancel, and now I finally have y by itself. Now on this side, I'm going to do 5 divided by 4. Again, that would give me a decimal, and I don't want that, so I'm just going to write it as 5/4. I know that it's positive because a -5 divided by a -4 is going to give me a positive answer. So this is 5/4 x. And then I have -4 over -4. If I do a negative divided by a negative, that gives me a positive. And when I do -4 divided by -4, that's +1. So now I have my y by itself. I can find my y-intercept. In this case, my y-intercept is +1 or +1. And I can find my slope. My slope here is 5/4. Or that's the same as -5 over -4. So when I graph this, I'm graphing my y-intercept of +1. So that's right here. And if I stop right there, oh, it's already intersected the first line. But I don't have a line here because I need at least 2 points to make a line. So I need to find one more point by using the slope. So I'll use my slope of, if I use +5 as my rise, I'm actually going to go, if I notice, 1, 2, 3, 4, 5 off of my graph. So I might be better off if I use my -5 over -4. So if I have -5 as my rise, I would move down 5. And then if I have -4 as my run, I would move left 4. So I would end up right here. So for this, this is what my second line would look like. So the solution for this is where these intersect. And what I notice is if I start at the origin, I don't have to move left or right to get to that point. That means that I have an x value of 0. And then I have to move up 1 to get to that point. So that means I have a y value of 1. All right, and this last one, if I have x plus 3y equals -12, I need to get y by itself, so I will subtract x from both sides. These would cancel and leave me with +3y. -12 and -x, I'm going to write that as -x minus 12. Now I'm going to divide by +3 on both sides of this equation, and that leaves me with y by itself. Now this is a -x over 3. Again, there is a 1 in front of that x that I don't see, so that's -1 over 3. A negative divided by a positive leaves me with a negative, so that fraction is going to be -1/3 x. Then I have -12, because of that minus sign, over +3. If I do -12 divided by +3, that gives me -4, so I write that as -4. Now I use all of that to find my slope and y-intercept. So my y-intercept here is -4, so -4. My slope is -1/3. I wrote it so that the negative was in my numerator, but it also can be written so that the numerator is positive and the denominator is negative. Now if I graph this, I'm going to start at my y-intercept, which is -4, so I'll go down to -4, and then I'm going to use my slope to find some more points. So if I start with this one, -1 over +3, that has a rise of -1, so that's down 1, and a run of +3, so that's right 3. Now, if I keep going from there, I'm going to end up off my graph. So if I go back to my y-intercept, I could also use +1 over -3. So that would be a rise of +1, so that's up 1, and a run of -3, and that's left 3. So those points would make up my first line. So if I graph that, my line would look something like this. All right, so now let's look at our second one. Our second one says 5x minus 3y equals -6. Again, I need y by itself, so I am going to subtract 5x from both sides. These are going to cancel and leave me with -3y equals, I have -6 minus 5x, so I'm going to write it as -5x minus 6. Now I need to divide both sides by -3. That's going to cancel these out and leave me with y. I have a -5 over -3, which is going to give me a decimal answer, so I'm just going to leave it as an improper fraction. And I know that if I have a negative over a negative, that's the same as a positive 5/3 x. Then I have -6 divided by -3, which is +2, so I write it as +2. Now, that means that I have a y-intercept of +2, and I have a slope of +5/3, which can also be written as -5 over -3. So I'm going to start this one by graphing my y-intercept of +2. And then if I use my slope of 5/3, that would give me a rise of +5, so I would have to go up 5. But if I go up 5, I'm going off my graph. I'm also going in the opposite direction of my other line, so that's not really going to help me. So instead, let's use our other slope, which is -5 over -3. And it looks different, but it is the same exact slope because a negative over a negative is a positive. So for this one, I'm going to go down 5. So down 1, 2, 3, 4, 5. And then I'm going to go left 3 because it has a run of -3. So I'm going to go left 1, 2, 3. And when I do that, I intersect with my first line. So I'm going to graph those points. So I will connect them with this line. I'm not doing that great of a job, but you get the idea. All right, so my point of intersection is this point right here. So to get there, I would move left 3 units. So my x value would be -3, and then I would move down 3 units. So my y value would also be -3. So the solution to this would be -3, -3.